so section 6.6 is logarithmic functions. Logarithmic and exponential equations we're learning to solve. So just a little reminder from our last section in notes of these two properties. They are going to come in very handy when we're solving. I did call these like the golden rules, where if you do something to one side of the equation, you do it to the other side. So if we just have something equal to something else and we're trying to figure out how to solve it because it has exponential stuff in it, then we can solve it with logarithms by taking the log of both sides. Or likewise, if we have a problem with logarithms on both sides, we can sometimes get rid of those logarithms and solve the exponentials that are left over after we take the logarithms away. The second property is what we're going to be able to do on this first example here. Just keep in mind when you're solving equations of any kind, you always do opposite or inverse operations. If an equation has addition, you subtract. If it has subtraction, you add. If it has multiplication, you divide. If it has division, it has multiplication. Those are your basic algebra problems. So for today's stuff, it's actually if it has logarithms, you use exponentials, and if it has exponentials, you use logarithms, because those are opposites of each other. Okay. So see here how we have the log base 5 on both sides. Yes, it must be the same base to use this property that we just talked about. And before we can just take and get rid of the logarithms, we actually have to use simplify this 2 appropriately so that we don't just end up with 2x when we've taken this away, because that would not be the correct answer. We actually need to take this 2 and put it back on the x as an exponent before we can go ahead and get rid of the logs on both sides, right? So now that we've done that, we have a log 5 on each side that we can now just get rid of on each side because it's the same base, and we're left with x squared equals 9. Then we can solve this by square roots, so our answers could be plus or minus 3. However, you must check your answers when your equation is a logarithm, a fraction, or a square root. So log, so check answers. You do not have to check the answers if the problem starts out as an exponential, but since it starts out as a logarithm, we must check it. So if we take our plus or minus 3, we plug 3 in. 3 squared is, well, 3 is fine to plug in here because we can do the log of 3. Okay, but if we try and plug in the negative into our original problem, see, we're going to look at our original problem here where the 2 was out front before we moved it, because you might get confused if you try and plug in your negative 3 and think, oh, well, it's negative 3 squared, which is a positive 9, so we can do that. But when in fact, remember that that 2 was out here to begin with. That means that you cannot plug in a negative 3 because you cannot take the logarithm of a negative, and that would just put the 2 out here. So the negative actually is not possible. So the final answer is x equals 3 because we can't take the log. That should have been a k. Log of negative 3.